I'm Piet, and I'm falling in for the master here because Cameron had a session, and he's somewhere in the army on the border of his country, trying to keep foreigners out. And so I picked up a nerdy technical topic. Now I realize it's not Cameron, and it's not as techy and as good as he used to do it, but you'd have to do. Here we go. Basically, I'm going to switch off my video to save on bandwidth. And that was it. Yes. Okay, the topic is the function result cache and how we fixed that. And a lot of this work was done by a colleague of mine called Peter Sweer. In case you're listening, Peter, hi, I'm still grateful. I'm an Oracle ace. I did 25 years of Oracle. I like to run around on a motorcycle through Europe. If you have an event in less than 2,000 kilometers from Amsterdam, I'll come and speak at the event, and I'd like to come by motorcycle. Customer list, you know what I've done. I did work like that for one day. Now, this is the moment where I ask, can you see my mouse? No. And this is what I usually do. I drink coffee at a desk, and I try to think about systems. Agenda, I'm going to tell you a little bit about history, how we did an investigation, the detective part, what we found, what kind of application this was, how we use result cache, and the result cache did not work. Now what? So then we had to look into that, and a colleague of mine came up with a couple of ideas, and we fixed it. At the end of this presentation, if I don't run out of time, there is a quiz question. Some of you can chase what is the number n, the critical number n. If I've got time, there's a 10-minute discussion. I know Eric, for example, has a few ideas about function result cache as well. Now, why do we do this? Well, this is a DevOps thing, sort of, if you want the keyword in DevOps. We had an application with really slow screens and slow reports. It took 30 seconds to move from one screen to the other. And that was unacceptable to the user, I can imagine. They tried to kill it with iron. They replaced a virtual machine stack with an Exadata, and it became only 3 times faster. So it's still more than 10 seconds to go from one screen to another. So now what? The user's not happy, operations suffer, management want a root cause analysis. So I put a file down in etc, I call it RCA, and I says, this is your root cause analysis. Never mind. We start by observing the system, and oh, by the way, it worked fine in dev. It is an ops problem now. Yeah, sort of. So you start looking at the system, you start your investigation, you start by observing. We didn't have OEM, we used something called Lab 128. That is still out there, although it's not continued anymore. And we tried to get them to run isolated test cases. We need to pinpoint the problem, basically. We used AWR a lot. I'll show you some AWR reports. Here is one. Now, this is absolutely clear. This is a CPU bottleneck. And this explains why we could tell them, if you go from your VM stack, an ESX farm somewhere, we could benchmark that. We knew the CPU speed on that. It will probably be about 2 to 3 times faster, but not more. And the Exadata the Exadata evangelists were like, yeah. But it did appear that moving from virtual machines to Exadata made it 3 times faster. How do you know? So, well, this thing is CPU bound, and you've got a CPU that is 3 times faster. It's that simple. So you keep looking, and we have a particularly high number of executes, and this was the little bomb in there. The user calls were fine, 99 per second. The parsers were okay, could have been less, but it's fine. This was the real problem. We just did things too often. We did too many executes. There were too many small steps to execute in that application. It wasn't a case of chattiness. It was purely a case of CPU speed, if you like. So we need to know, what is this for an application? And then you start looking into this Russian doll thing, and you find out that it's a very rich application. it does a lot of things. It was very flexible. It uses view to define objects or things. It used an awful lot of generated code. We will see some 4,000 packages in here. It uses the views with instead of triggers. So this was a very cleverly coded application. The views called functions. So in a view, you get a select from a function. The function is contained in a package, which is fine. And those functions were used in the select and in the where clause of the view. The functions were mostly something like get the name of something using an ID and return a varchar. That becomes understandable. Those functions mainly queried a view called objects. That object was a view over 1, 3, 6 tables. Interesting. Let me try and explain. Now, this is where I like to look at the audience. You guys with me, or is everyone just leaving and go, oh, this is too complicated? But it is sometimes. What we had was a lot of layers in the application. Here we go. We had 1, 3, 6 small tables, and they were contained in a view called object. We had 2,000 other tables, but only a few of those tables actually contain records. Tables with, you guess what, views on them. Not just some views, no, just about 3 times more views than we had tables. Huh? Okay, fine. And then we got 4,200 packages, 18 of which depended on objects, so that view here, and the packages contain the functions. I got my packages with the functions in them, and the functions return varchars, most of them. And there is a view layer that calls the functions. And those functions form the columns in the view. And the views also had instead of triggers, so you could do a limited amount of insert, update, and delete. So there's my view layer with all the triggers on them. And then I get to the screens, put up some trendy MacBooks, and I had reports. And by the way, some of the reports had M views to help them make faster. Now, this is where I really look at the audience. Are you with me? Okay, good. That's it. This was my application. Now, where was my problem? Let's have a look at that. The CPU effort went into the function calls from the view. So whenever you query the view, you end up with a hiccup of CPU activity, if you like, and a lot of executes. Here's what we think is the root cause. Here's your RCA. We have a rich view. We have a view. The view contains columns. The columns are functions. So here you go, package, function argument, returning an attribute, a varchar. So this view returns 1 function, 2 functions, etc. And they query tables, and there is often a where clause, and the where clause could contain those functions. So you end up with a function call here in select, or 2, or 3, or 7. And you end up with function calls in the where clause being executed. And this is where the number of executes come from. Then they use those views, so you got one view and another view, and you join them. So you select a couple of fields, and you join using functions, and you put some filters on, and those columns, again, are functions and functions. So the columns in the view cause function calls. The joins from the view cause function calls, and the where filters in the view cause function calls. This becomes a real CPU hiccup. And there you've got your CPU little man running. So you explain that, and people had already done that. If you auto-explain something like this, select a column from some table with a function call in it, where the key is the argument, that's fine, you know. That is probably 3 or 4 block gets, because you go directly to the right record in the table, you pick up the ID, that's it. Auto-explain, no problem. Auto-trace shows thousands of block gets, and that becomes weird. How can my explain look simple and my trace still indicate a lot of activity? Well, of course, it's the function calls. And then in the report, you start to aggregate queries like this. that really becomes a 10,000 executes or whatever for just one report. That's why the reports take so long. So this is your system, hard at work. And how are we going to help these users? Because the boss is just, okay, you need to do something. You're the Oracle experts, you fix it. And we were like scratching our heads. This is where in front of an audience, I scratch my head. So the first thing you think of is, can we do better cache? Well, probably not, because all the data is already in the cache and it's just CPU running around. Can we maybe put stuff in arrays instead of calling the functions all the time? Code our own cache if you like. That would still give me irregular responses, and I would become responsible for managing those arrays. Not a very good idea. And by the way, somebody should now raise a hand and say, whoa, if you do that, you bypass the ACID properties of the database altogether. Not a good idea. Maybe we could use function result cache. And we tried that, and it didn't work. So this was like, what? And then we investigated further. Peter gave me the final idea, came up with a really good workaround, and that's where this PowerPoint came from. And remember, there is the magic number N in the quiz that I want you to look after. So the other solutions were, can we eliminate code? Can we maybe do less code in this application? So we removed some codes from the views. We asked the dev team, we got a sort of a blank response, like, yeah, maybe. And look at the top SQL, find your problem SQL if you can, and try to remove columns from the views in that SQL. And if you remove columns, you end up with less executes. That's a good sign. So we got confirmation that those columns did cause the executes and did cause the slowness. We ended up by creating clone views with just a few necessary columns. And then we sort of cross our fingers that nothing breaks. This is old-fashioned stuff. You just put comment and hope it still runs. The result was less calls, less frequent calls, and slightly better responses on screens. We also eliminated some of the M views. If we did that, and if we keep doing that, we end up with maintenance in future, because on the next version of the system, we have to go in and tweak those views, comment out stuff. We need to be doing that until the end of time if we go this way. And it's not our code. Remember, this code was architected somewhere in Scandinavia and is currently under maintenance by a team in India. And then when it gets rolled out, we have to go in and fix it again. Not a very productive idea. No. Can somebody put a sign of life in chat that they're still listening, or is everyone dozing away now? Okay. So eliminating code did work. We put our comments in the column in the views there, and that helped. It gave us a good indication we were onto something. So we need to do less calls. So there was another solution. We could try to bypass and go find the data. We did that for the heavy reports and some of the frequency stuff. But it means you have to find out the logic to bypass, and that's expensive, and you end up with hard-coded stuff, and again with a lot of maintenance. But you can bypass for reports. If you know what goes in this report, you can bypass it and query the data directly and join it to what you need to make it readable. It was a solution, again, not ideal. So we go back to our result cache function, and this is where I check my timing. The challenge of any cache, any result cache, is data will change, especially when the system is in use. And this system was heavily used at the end of each month. That's where the panic came from. The challenge is also, I cannot really touch the generated code. I don't want to end up with maintenance whenever a new release comes out. And maybe they change the whole concept, and I can't really help. So try not to touch somebody else's code if I can. The clue, of course, was if we eliminate functions, that made the SQL faster. Didn't quite make it fly, but it made it faster. A very good indication. So we were going further. We put on more duct tape. We would like to use the function result cache. We looked like we had an ideal use case for it because we had a lot of function calls. The demo of function result set, of course, works. You can test it out on mscot, mdep, and find out that you can actually speed up things with a result cache. That's fine. The demo is nice, but on our system, we could do as much keyword as we want. Didn't work. Now what? This is where Eric raises his finger and says, yeah, I know. So what is function result cache? Let's do a quick intro. And this is where you ask the room. And somebody raise their hands if you've heard of function result cache and have an idea what we do. Because you all type in yes in the chat if you do. You can try. So function result cache came in Oracle 11. It caches the result of queries or PL/SQL functions. It caches that in memory, of course. It is a cache that is separate from, it's not the buffer cache. It has its own space in the SGA. And the first type is the server result cache. This is what we used. The cache is defined and stored in the queries, and it can store query results. Sorry. The cache is defined at the server. You can cache result sets from queries, rows, or you can cache return values of functions. And this is what we did. It uses part of the shared pool, so you may have to increase your shared pool. We'll come to that. And the results are available across sessions. So if you have 500 sessions calling those functions, they can use each other's cache. That comes in quite handy. You know, as opposed to, for example, Postgres wouldn't be able to do this because they don't have a shared pool. There is also a client result cache, and that is not the topic of this presentation. So if you think of caching stuff on your client, be my guest, but this is not what this talk is about. The result cache is part of the Oracle shared memory. It's not the buffer cache, so this is not going to cost you buffer cache. It goes in the shared pool. It has its own space defined there, and you are responsible for setting a value for that cache. And we'll come to that because if you need to remember one thing, the default is too small, at least in our case. So you continue reading the manual. Whenever you execute a function, it searches for the same function call. Have I already done that function call with those arguments? It hashes the arguments, of course. If that function's already been called with exactly those arguments, it reads the result from the cache, and the function is not executed. Your execute count goes down, and that's what we wanted. If it doesn't find the result, it executes the function and puts the result in the cache. And bingo, the next call can find it there. This cache contains of 1 kilobyte blocks, and every result will be contained in one block. So your result better fit in a 1 kilobyte value. That's not a big problem. A result can span multiple blocks if that's needed. So if you get a large piece of text, a large varchar, that's more than a kilobyte, it can store that in multiple blocks. We didn't have that, by the way. We had strings of about 30 to 60 in length, and it was mainly because of various translations. So the system would translate into whatever language you preferred. So strings cached, basically. If you repeat the execution of the function, the execute count doesn't go up. You will find that there is almost no extra CPU effort for the subsequent calls to the function. You can demo that by building a really heavy function, putting it as a result cache function, and see for yourself that on the second and subsequent call, there is no CPU effort spent anymore. It's beautiful. The cache gets in. So how do you keep the cache? Well, this is where Oracle does its magic. Oracle keeps track of how the cache is dependent on objects. And if an object is modified, the cache becomes invalid. You can see that by updating a record under one of your results, and then you see that suddenly there is an execute count because it needs to re-fetch that result. So Oracle does this for you. This is beautiful. This is a caching mechanism, and I don't have to code it myself. Bingo. I would expect a load of questions by now. Anything in the Q&A yet? Okay, not yet. So there are some, it's not all roses, of course. There are some restrictions. It has to be, the return type has to be a varchar, a number, or a date. So you cannot return composite values, for example. You cannot return defined values by yourself, but you can, if you like, try to return a collection of values. In our case, I think we only had varchar results, so we were safe here. And it cannot include any dictionary. So this can't be dependent on dictionary tables, can't be dependent on temporary tables, cannot use sequences for obvious reasons, cannot use pseudo columns. I wonder where the pseudo columns are from. Cannot contain date or time functions, and cannot have non-deterministic functions. It kind of makes sense. You can only cache a function if the result is predictable. Yeah, think about it. But keep in mind the restriction. I wouldn't mind having dictionary tables in there, by the way. Anyway. There are a bit more still on the restrictions. It has to be a function with invokers. It's not supported if you have a function with invokers rights. That can be an objection. Cannot work for pipeline table functions, more or less for obvious reasons. Cannot have out or in-out parameters. So you cannot modify other parameters. Makes sense if you think about it. Doesn't work with lobs, cannot be a ref cursor, cannot be an object or record type in parameters. This is more or less a question of read the manual. Make a note of this one. If you use the force keyword, result cache mode is force, you end up with either a CPU problem or a hanging system or a total crash. So if you want to be careful, and this is for Oracle 12.1, if I recall correctly, so it might be fixed by now, but if you are thinking of using result cache, take a copy of this slide, take a picture, or wait for the slides to come online. The parameters you need to set, I've only got one message really. The result cache max size, the default will be too small. You'd have to determine for yourself how many results would you expect to get, or how much do you want to cache, and set your value by yourself. And remember, the result cache uses 1 kilobyte for each result. So if you think you have 1,000 results, you need 1,000 kilobyte blocks, you need a meg. Questions about this? It is a bit of a waste if you just need a number, and a number is something in the order of maybe 10 or 15 bytes. That means you have the rest of a kilobyte unused. If you return small strings, like in our case, small varchars, it'd be about 30, 60, maybe 100 bytes per string, per varchar. You have another 900 bytes in that memory block unused. Wasn't too happy with it, but this is how it is. So, there's some tools, and the disclaimer is we did not use any of those. We tried the flush a couple of times, but you can manage some of the result cache by the contents of a package called, of course, dbms result cache. You can flush, you can try to report, you can bypass, you can force an invalidate of the cache, you can force an invalidate of an object if you like. We didn't research any of this. We were happy it worked, and we didn't really mess with the whole parameter, with the whole setting here. You can view whether your result cache is being used. There's a few $V result cache views for that as well. I recommend you sort of monitor from here. So here we go. We tried it. We added the result cache keyword to our functions, and that can be a packaged function, can be a standalone function, and then Oracle will track the dependencies. You don't have to do any of that. There's an old parameter, relies on, is deprecated, so don't use it. And result cache should be most effective for something like a repetitive, high-frequency function call. And we had that, remember? We had functions that would use the ID to pick up the name in any language of an object. We had exactly that sort of workload. And the date that we were querying would be more or less persistent with a very low change rate. We doubted that at month end. We would expect more changes possibly than was healthy for our result cache, but in the end it happened, it worked. So we thought we had the perfect use case for it all. We did a call to the same function many times, even in one session. So, all roses. Let's use this. In our case, we got this get something based on the ID, return the varchar. That was used in many of those views, identical calls. We had small and efficient queries inside the function. We had a bit of context switching there, but we would be, this would, if we could avoid the function call, we would avoid the context switch. It would just be happy for us. We had really good candidates. Let's try. And we added the result. It didn't work. In our real life, we had no benefit whatsoever. AWR came out exactly the same. Test failed, basically. We were a bit disappointed. Let me show you where we were. Our functions were in this part of the application, the view with all the columns. The columns are functions, the functions get called, and the functions were ideal candidates for result cache. And that didn't work. So we read the manual. You can have a look somewhere here. And this was our main use case. We were trying to call this particular object view to get names and descriptions from objects, and it didn't work. You got the message, it didn't work. So we get this, we use the result cache. Multiple queries were to a view, which was a union of 136 tables. Basically, we were fishing data out of those little tables. There was a bit of logic in there, a bit of formatting stuff, but not much. So why didn't it work? We thought, and we kind of figured by testing, too many dependencies. Let's show. We get a function, result cache, select a name from a union view, where the key is key. So we return just one row, and you do some other SQL work, and you return the function, and that's the end of the function. The dependencies of this function are in this union view, and there are 136 tables under this view, and that was what stopped us from properly using it. It took us over a week to find that, but there you go. We finally found it. If we create smaller queries, so every demo we tried always worked. We ended up trying union views in the function, and as long as you have a small number of tables or a small number of dependencies for the function, it would work, and above a certain number of dependencies, it would stop working. And by now you should be able to find that in support. But when we found this, we thought we were the first person to find it. Okay. And Bryn Llewellyn later confirmed that we may not have been the first, but we had our number correct. So we tested that with a union of 2, a union of 5 tables, a union of 10 tables, a union of 20 tables. And at a certain number, it would stop working. It's like a car crash almost. And we had to do 136 tables in a union. We had 136 dependencies at least. Yeah. And this is where it stopped. It didn't work. Now what? Next time if I got. This is where I check my time, basically. So your question at the end of this PowerPoint is go out into the world and find us N and then report that back to Mirella or something. We are here, we are in a package, we have a function calling a query on a view. The view has too many tables in it. What are we going to do? It took us a day of despair, and then the next day it was Peter who said, well, we just need less, so we need smaller views. Yeah, can we do that? Yeah. Well, smaller views with less tables. So you end up not with one big view, or you still end up with one. You end up with a lot of small views, each containing just below n of the tables. And then you create functions to fetch from the smaller views. And each of those functions will, of course, only have the number of dependencies of that view. So it could be 10 tables in each union. So you would have 10 or 11 dependencies with that function. And then the function could be cached. Brilliant. You could cache each of those functions. And even better, if you didn't find your result in the first view, or if you did find it in the first view, you didn't have to call on the other views. You could skip a number of the queries. So you had to recode the function called getSomething into a getSomething 1, 2, 3, 4. Every function got 4 or 5 siblings, 4 or 5 children, if you like, smaller functions. You call those functions one by one until you find the data. And of course, you try to go for the most likely one first. So you try to figure out, well, it's probably part of those tables, so put those in the first call, etc. And the effect was we got it back working. Now, this is what I need a whiteboard to draw more details. And I would fully expect half of the audience to be lost by now, but that's okay. If you review the slides, you could probably get it. It's not that difficult. Let me try and explain. So we have a function here that used to call a view with all the tables. Now we split that view into smaller ones, each of those views calling only a small number of tables. So you could call this view and have your result out of it. You get less dependencies for the small function, for the small views, if you like. So you make this call, and if you got your result, you're happy, and you can return, and control goes to the next part of the query. If you didn't find it, you call on the next one. If you still can't find the result, you call the next one, etc., until you've got your result, or maybe not if the query doesn't return anything. And this particular function, you still cannot cache because it has too many dependencies. But the small ones here can all be cached because they have a very small or a small enough number of dependencies. And that's when function result cache begins to work. Now, it's still a maintenance nightmare, of course, but at least we got it working. This is where you look at the audience and go, questions? Anyone? No. Let me summarize. The function result cache, in our case, was very powerful. It helped. It worked. We got it to work. If you want to use it, it is something you can fairly easily do. You put in that one keyword. If you have all the requirements set, if you are within the limits, you have a simple enough function, you have a few dependencies, the function is deterministic, etc. By the way, it doesn't work in a with clause. Eric told you that about 2 hours ago. Once you have that case, you put in the keyword and sort of by magic, things become faster. It saves you CPU, it can save you IO by caching your results. So that's beautiful. Now, however, you have to configure it properly. Your default cache size is probably too small. Check that. Don't use the force keyword or your system will hang, or use the hang in Oracle 12. So you have to use this with a certain care. And you have to check the documented and undocumented limitations. And our undocumented limitation, of course, was that famous number n for the number of dependencies. So here's your quiz. You go home now and find out what n is. Some of you may already have gotten it via Google or from Metalink support. Yeah. So that was my... Then, of all the fixes we tried the function result cache, we tried to eliminate code, we tried to bypass queries. They all worked somehow, but the function result cache was the best one. I did not have to rewrite the total app yet, and I don't really want to do that. I'm not clever enough for that. There's a lot of intelligence in this application. So if you recognize that this is your application or your colleagues are building or maintaining this, I have a lot of respect for you guys. I really don't want to criticize the concept. It's good. This application has something like more than 10, but less than 100 users out in the world. This application was written with the best intentions, and whoever made it was very clever. However, whenever you build something like this, please test early, and test with a realistic volume and a realistic number of tables. Think about how your system is getting used. Maybe you can eliminate some of the code already. And then when it gets into production, stay with it, monitor it. This is the DevOps part. Maybe this particular application was never intended the way my client used it. And then evaluate, monitor what happens in real life and think about your application again when we tried to talk to the developers on this, they were a bit, yeah, no. Oops. Now, I'm going to do first the question and answer probably. Can I get the Q&A somewhere? No. Mirela, can you get to Q&A?
Yes, it's one question. Do you think rewriting the code would be a permanent solution, or this one is having advantage?
Oh, yeah, that's a good one. For what this application tries to do, and notably it is multi-dimensional, multilingual, so it can handle many languages, and it's just a matter of flipping a button to change the language on the front end. It can handle many units of measurement. You know, this was used to translate stuff into local measurements. We use meters. The Americans and the English use feet. And the application handles all that very smoothly, but it does that with functions and complexity, if you like. Yeah. So I would probably not rewrite the code for this application, but no, I don't really have a good answer to that. So I have a lot of respect for the people who built it, and it was not their fault that it didn't work. My main warning is, if you build something really complex, you know, test it and think about it and monitor it and stay with it. You know, keep an eye on it. Does that help, Babu Srinivasan? Is that a good enough answer? Because that's all I have at the moment.
So you managed to open the Q&A. There is another question.
You probably see my screen by now.
Yeah, another question, and there is also a kind of comment in chat. Please, we have time to have a look at both.
Does it affect? Yes, it affects the result cache in two ways. Because flushing the shared pool you will have to reparse all the queries and all the statements anyway. So yes, flushing the shared pool has a knock-on effect on the function result cache. Yeah. You said there was something in chat. So that is, hey, I can click that. And chat, how do I get to chat? Chat. You guys are probably seeing my screen, right? I got, thanks for showing light. You have an application. Am I early, by the way? Are we early?
Oh. Yeah, we have time. You are early.
We've run on the ledge weight. Yes, of course. Is this on the last question? Yeah, that makes perfect sense. If the data changes a lot, the mechanism that keeps track of the changes, the mechanism that ensures that the cache is correct, is going to work overtime. There has to be a latching or a locking mechanism around this cache, around each block, actually. This is one of the reasons why the result cache, every result is in a 1K block. You know, some of the details are, if you cache just a number or a string in our case, a lot of that block is needed to keep track of the dependencies. That block has pointers or receives pointers from dependent data, actually. And yes, if you change the data, it will have an effect on the cache. No. And we never tested that. I'm not surprised that it shows up as a latch weight. Gabriel, do you have any more details on the latch or on the phenomena that you see? Like, how did you spot it and what kind of latch? Is that because that would be an interesting case to test. Yeah. And then any other chats? Patrick, we have an application. We have an application very similar. We evaluated result cache. It was latch contention on the result cache latch. Yes, of course. Patrick, in that case, your data probably changes too quick. Does that make sense? And again, Patrick, if you want to prevent that sort of contention, maybe only use result cache on functions that have little or no dependencies. And there's another question. With all the findings that you come out with, what are the use cases that can benefit? Yes, on that one. basically, I agree with the manual. It works on relatively simple functions that return a single value and that have a high frequency of call. It is exactly what the manual states. We thought we had a good use case. And where we went wrong is when we used functions or packages that had too much dependencies. So if you want to evaluate your own situation, you have to go through the functions that you want to use cached. So where would you put the keyword? At which function? And if you think that function has more than n dependencies, and by the way, n is somewhere between 10 and 50, and the exact number is a quiz. If you have a function with a lot of dependencies, it won't work. That's the short answer. Does that help? Okay, any other?
It was one before this performance overhead observed with this wait events contention expected on shared pool.
In our case, not, because when our function result cache didn't work, nothing went into the result cache, and our CPU was just high, like it was before the test. And when it did work, we did find fairly quickly that we had a lot of result cache coming in and out, so we had to increase the number, and that was about it. So we haven't really observed additional wait events. Now remember, even before this, we fixed this system mainly didn't have wait events. It had the busy CPU. So the top 5 events were not relevant. Only the CPU event in there was relevant. And CPU is not really a wait event, it's just busy. So I don't have a good list of wait events, and I don't have an if-then, like if you see this wait event, then you need to use function result cache. Basically, you will need to use, or you can use function result cache if you have a high CPU and if you find or you know that you have a lot of calls to functions with the same arguments. Does that make sense? Should I? I'm still here.
Yeah, and we are still here. I think that's all. I don't see anything else in chat. Yes, thank you. The person who asked the question,
there we go.
It's okay.
Thanks. Yeah. And if you guys want to discuss more, my Twitter DM is open, and I think my email is out. I have the final slide here somewhere as well. Did I? I did actually. This is time. Yeah. My last minute. This is my final slide. I can, whatever you do. This is my blog post, and investigate for yourself. Do your homework. Find out the dependencies. It's on MetaLink somewhere. Whatever you do, keep it simple. Don't build anything too complicated. And if you build something complicated, be prepared to explain it to your colleagues. A sustainable system, a system that wants to live long, has to be explicable to your colleagues and to your successor. That would be one of my main messages. Thank you.
And the last question, we are not taking anything except that one.
Where are we?
Did you try using the caching tables as well?
I'm not quite clear on that, because caching tables is what Oracle does automatically. The Oracle data buffer caches the data, and this data was already in cache. If you remember the AWR from the beginning of the presentation, there was hardly any I/O. All the data was picked up from the Oracle buffer cache already. So that wasn't something we could optimize further. And what we did not do is we did not code our own arrays, or we did not code PL/SQL tables, if that is the question. And also we didn't pin tables in the cache. There was no need to put cache properties on the tables because everything was in cache already. Is that the answer you're looking for? Did I get that question right? Okay.
I suppose so.
Yeah, I can type whatever I want, but my typing goes to the wrong type. I will,
Yeah.
yeah, okay, I'll ping you offline. Thanks, Kathy.
Okay, thank you so much, Pete.